Hi, I think I got disconnected. I've started the recording again. The recording, yeah. So, all right, I was telling you a joke actually. Yeah, I met somebody who was telling that they have bought a machine with 96 GB RAM because they needed 8 nodes and they created 8 virtual machines out of it and are running running Hadoop on it. And, you know, the second story I mean, in continuation with the above one, they were, their point was, we are not able to acquire bigger disk than 4 TB for our node. Okay. Now, all right. So it's the same story. They needed 8 nodes. They bought a machine with 96 GB RAM and created 8 virtual machines and are running Hadoop on these. Hadoop along with Spark. All right. And in follow up with they also told me that they are not able to acquire bigger disk than 4 terabyte of disk. Okay. My question here was, do you need 4 TB disk? Isn't Aren't 1 TB into 4 better? Alright, so do you get the joke, I think? Or should I explain? It's very important to basically understand what are the various components that matter in computing. Alright, never mind. Never mind. Yeah. So now we are going to start something very interesting. Alright, and here we go before we delay further. Alright, here we go. I hope there are no questions before I start. If you have any questions, feel free to ask. All right. So at various point of time, you will find yourself running a new kind of programs. Whenever we defined a program, we always told that a program ends. In case of streaming, program never ends. They keep on waiting for data. Either they are waiting for the data, or they are processing the data, or they are writing the data. So such programs are called stream processing engines, or are generally called stream processors. The data stream keeps coming from various sources. It could be as simple as that these programs are monitoring one particular folder. As and when files are being added into that folder, they are picking those files. Or it could be very sophisticated like Kafka. The whole organization is writing the data into Kafka, and these programs are reading from Kafka. And these programs are written by you and me and other developers. So in an organization, it's a common practice to have a single message bus. Let's take an example of any e-commerce company. As soon as a user places an order, an event is pushed into a common central system, and from there, whosoever is listening to this event consumes this event and then does the action. Okay, so take a case of an take a case of one order being placed in an e-commerce website. The moment user clicks on place order, the there's an event that's getting raised saying order ID this, product ID this, delivery details of this has been placed. Now whosoever want to listen to it. Now there will be emailer who will listen to this event called this event called item added or order placed. So to the event called order placed, there are many listeners in this queue. So on one end, the website pushed an event called order placed. On other end, there are many listeners to the events. They're listening to all kinds of events. Some so let's take a case of the event notification, SMS notification, and they will all listen to the order placed event. Similarly, legal department, credit card checks, and delivery guys and availability guys, all of them will listen to this event, and as soon as order is placed, a notification goes to all, they will take their action and do the work. All right, so this is the role of queue or stream processing. All right, say for example you want to do a real-time sentiment analysis of Twitter. So what you do is you keep on reading data from Twitter in real time and keep on pushing the number of keywords found onto the server. Okay, and present the output onto dashboard. So stream processing. So first part we talked about queue. What is the meaning of queue? Queue is generally considered like a big event bus, which is not in memory but is on the disk and is very resilient. So one of the queues example is Kafka and message queue, MQ, 0MQ, and there are many more in the industry. All right. Second part is stream processing. Stream processing means reading data from continuous sources of data, and then process them and save them into somewhere. Okay. So that's where Spark fits in. Spark gives us the ability to run our code onto this continuously coming data. Because Spark's computing is fairly fast and is based on a concept called RDD, Resilience Distributed Dataset. And this Resilience Distributed Dataset can be created in real time from the data that is coming in. Okay, so generally what it does is when the data is coming in, all right. So Spark Streaming is not like a new fresh product. It's just a library. You don't need to install Spark Streaming separately. It is by default there. All right. You don't need to run another service. So it's just a library on top of Spark. All right. So it utilizes Spark in newer ways. Basically, this library reads data from input, keeps creating the RDD based on various timestamps. And that's how it does the work. All right. Now, this is what we mean by stream processing. Okay. The input data of stream keeps coming, and we keep on breaking it down into batches of input data and then compute. Okay. And in case of Spark, Spark provides you a class called dStream, which is discretized stream, okay, which is a continuous stream of data broken down into batches. All right. The general workflow is that Spark Streaming API would read from continuous sources of data, and then it will divide that input data into batches, into something we call something we call as window or a batch. Okay, so it divides it into batches of an ideal size would be say 5 seconds. So every 5 seconds it will take the data, put it into RDD, and give the RDD for processing to us. The next batch of data will go into another RDD, and then that will be processed after in the next round. Okay, so it keeps on reading the data, preparing the batches and in the form of RDD, and gives you the complete control of running things over that batch of data. Okay, so Spark Engine generates the final stream of results in batches. All right, so if you look at it, it's nothing so big deal. All it does is it reads the data, creates an RDD, and then runs the usual Spark or usual Spark code on that RDD. That's it. Yes, it is always based on time in milliseconds, not seconds, but in milliseconds. All right, so yeah, Ishwar's question is it always based on time? Can't we do something based on amount of data? Okay, so streaming is all about time. Amount of data you can handle by our traditional means, right? What you're saying is as the data grows bigger, we should spill it over to more RDD or something like that, right? Yeah, so that we can do it traditionally as well. It's not difficult. And also, even if this guy was not there, even if D stream was not there, it is not a big deal to write our own D stream. All right. All we need to do is read the data from sources continuously every 1 second or whatever second you want, and then for that we create an RDD. We give the data to our to our streaming. And today we are going to show you that how Spark can handle few lakh requests in a second. All right, few lakh elements in a second. Sounds good. Now, all right, all right. So you can see here. This is how it has broken down the data into the batches. You can see that the stream continuously is coming, input is coming and is being broken down into an RDD. Every batch is an RDD. Data on time 1, data on time 2, data on time 3, data on time 4, and so on. And for each one we are executing our logic. All right, and it also provides something called window operations. We will cover window operations later. Let's try to jump in. I think there is nothing better than doing it hands on. All right, and at the end of this session you should all try to do the same thing. It's very straightforward and simple. All right, we will go through this one step at a time and we will try to run it. Okay, let's just try to create. We don't need to, if we are creating a program, we will need to do this. We'll need to create Spark context, but if we are running from here, let's try to run from the program itself. All right, so I have given all of you H1's password. You can also log in there. I will also log in there. And yeah, all right. So I'll not log in. Yeah, log in from this command SSH is not possible. So you will have to log in here from the web. All right. You will have to log in here h1.cloudxlab. Yeah. All right. Good. I'll open one more terminal because I'll create one consumer and one producer parallelly. And great. If in case anybody else is doing, you can try other. Instead of h1 you can try h2.cloudxlab. All right. So I've opened two terminal, 1 and 2. All right. Good. Here we go. Is this screen clearly visible to everyone? Is the font clearly visible or should I increase the font? All right. Good. Great. So let's start, and we will basically open the Hadoop fs minus ls slash data. So I've also copied this data in this folder. I'll just copy to local slash data ss. All right. Here we have, let's take the simpler most example. All right. So we are creating, first of all, we are creating the PySpark as in the import. So here, first of all, we do the imports. We need Spark context as well as we need streaming context. Once we have done that, let's create the Spark context using here. So we could also use interactive. In those cases, we don't need this particular line. And then we create the Spark streaming context. And what does it mean? Here we are saying every 1 minute we want to process. We want to process the data every 1 minute. All right. And then every 1 minute we are reading the data, and then we are creating the D stream that will connect to host name and port, and this is the format. So here we are connecting to this particular port at this host, okay, which means it this SSE, this stream context, this streaming context is going to read the data from this host listening at this port. Okay, so we will have to run a server at this port which will keep on spitting the data continuously, and then we will feed that to the streaming, and then streaming context will run the job. The step number 2, after you have set up, you do the usual word count. Okay, so here we have created lines. Lines is an RDD which is being prepared, which is basically a Spark streaming RDD which will be continuously prepared. And here we are saying words equals to lines.flatmap, pairs equals to words.map, and then word count equals to pairs.reduce by key. And once we have written this is our word count, usual word count, we have gone through it multiple times. Once we are done with it, we print it. We say word counts dot pprint. Please note the pprint part, because it is a little different. It is little tricky, because there is no while loop, there is no for loop. Then how will it keep printing every 1 second? The thing is here, when we say lines dot flat map, we are not really calling our usual RDD. This lines internally has made basically a representation which will keep on executing all of this together. All right. Now, to start the computation, we can say Spark streaming context dot start, and then wait for its termination. All right. Is it clear? The first part is establishing a connection and creating the data by reading this particular port. And then second is doing the flat map, doing the map, and then doing the reduce by key. Also, printing it. P-printing gets executed every time the stream finishes the work on one RDD. And then we start the process, we wait for its termination, and then see the magic. Alright? Now let's see the magic. Also, please note that if you want to avoid all this information, when you run this, I'll just do an export. Alright, not here, not here, not here. Here. So when we say something like this, what is it going to do is it is going to show a lot of information on the screen. You see that? Lot of information. So we can redirect it. You can redirect it to dev null, as in send all this to greater than dev null means send all the errors to dev null. All right. So here it's trying to read data from somewhere, and it's saying that nothing is found. Now let's try to open nc minus l. Nc minus l means that we are going to create listening to 999 port. Okay. Sorry. All right. Let it come finish. All right, it has got cancelled. All right, let me just one more thing I need to check. Spark streaming.py. Here, what is the port? Let me just change this port to 998. It seems that somebody has blocked that port. I'm just changing it to 998. All right, now I'll just show you how to create a small server. So right now, if I say this nc minus l 998, now I can connect to this server from anywhere. So nc is a great, say I use from here. I think telnet is there. No, telnet is not there. So I can say ssh, not ssh. I can say nc, and I can connect to this one, nc localhost. You see that when we are writing this, you can see we are able to communicate with each other. It's probably the easiest chat server you could ever think. See that? So we are able to connect to this particular node. So by whenever you say nc minus l 9998, it has created a service which is listening to 9998, and whatever it listens, it prints on the screen. And whatever you type here, it gets given. It is given to the client. All right. So here we have created this tiny little server. All right, here is our server. Now we are creating, so our Spark streaming is going to run, read the data from there. All right, two greater than dev null is redirecting all the information from std out, std error to the disk. Now it says that there is nothing found. Now we will start writing something and see if it is there. Now you can see it has come. It shows that dd has come once and dd has come once, dd come two. All right, so we have, sounds good. So whatever we are typing here, that's being counted. All right, hi, this is great. Now you can see where is the, it is scrolled down by now. See, it's continuously computing. This is stream processing. It is in real time. It's computing every 1 second, every exactly 1 second. It's printing the total number of records received. Sounds interesting? Yeah? Is it clear? Is there any step which sounds very mysterious or magical which you did not get? All right, let's try to do something really, really fast. Okay, so there is a command called yes. If you type yes command, it infinitely print y on the screen. It keeps on printing y on the screen. All right, now let's try to flood our stream processing with y's. What do you say? And then see how many requests can it handle per second. All right, good. Now let's try to flood. So is everybody clear? So there is this command called yes. Okay, it keeps on indefinitely printing y on the screen. I put more, that's why I'm able to stop it. Sounds good. Now let's try to flood our, so we started this server which listens on 998 port. We can say yes to it. So which means anybody who comes in to connect to this service will only see yes on the screen. Okay, y on the screen. And yes is a standard command. If you want to automate lots of stuff and you just want to keep on automating installation, if you want to just say yes, y, then this is a good tool. All right, now so we are saying yes, 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 yes. We are basically producing continuously a stream of yeses. Okay, now let's start this and at the same time start the stream processing. All right, now see the game. So at one end, that guy is just printing this yes is just printing y on this particular port. Whosoever connects to 9980 9998 port, he will only see y's. Now this is the stream processing which is connected to the same way. Okay, now you can see that it's consuming around 9.9 lakh, sometimes 6.8 lakh, no, 68,000, here 3.4 lakhs, all right, continuously. So these many Ys it's receiving per second. Do you see that? Do you see that? It has found Y here. This is 2.3 lakh, this is 5.8 lakh per second, this is 9.4 lakh, and this is 8.5 lakh. Now do you understand the meaning of stream processing? We are processing around 7 lakh uh, 7 lakh words per second. Here, see, in this last second, it came to around 10 lakh. And if you see the CPU, it will be on the highest possible. Okay. If you want to send a running process into background, you can press Control Z and type BG. And here, if you see here, this is the process that's consuming everything. Do you see? CPU percentage equals to 141%. All right. So let's see whether it's running on the cluster or is it running locally. It's of course running locally. All right. It's running locally because we have not mentioned the master. All right. So here you can see in case of the other one, in case of the other, what do you call, um, when we talk about Kafka, then we will run it on the we will run it on the production on the cluster. All right. There's not much of a difference. You can just say master yarn and it will go there, and maybe it's already there. Let me just check. How did we specify anywhere? All right. So it's still running in local mode. All right. So everybody clear about what does it mean by stream processing? Jitendra, does it sound interesting to you? We basically produced around 10 lakh requests per second. So an RDD with an element of 10 lakh in a second. That's what we were doing. The RAM is around 8 gigabyte. So these are the hosts. So there are 8 GB RAMs. All right, let's move and understand the next challenge. The next challenge which we want to say, so here this side was our listener speaker. It was saying yes, yes continuously, and here it was counting those Y's. And yeah, So all of this is also available if you are in H1. This is the new cluster which we are setting up. Here the hue is available on 888 port rather than 8000 ports, because 888 ports are more available in organizations than 8800, because most of them have the firewall. All right. So here you can see I have created here. You can download this whole data. So these are the this one is the one which we just ran. Okay, and this one is containing only the shell script. All right, have I started the recording? Yeah. In the last session I forgot to start the recording after the when the connection resumed. Oh, I think it was running on, which port is this? All right. Great, great. So this was a good exercise. Now let's move ahead and try to do Kafka. All right. So these are the various examples on how did I run it. So this was first I tried to type in few things, and then I said yes, and I piped yes, all the data coming from yes to our NC, which means anybody who connects to NC at this port will see only Y on the screen. Sounds good? All right. Now, for some people who are trying to do the stream processing, they might want to try out Maven or other. Sorry, some of us would like to try out stream processing in other languages. The library remains same. There is a dstream library which takes the Spark context, and then it provides you all functions like map, reduce, and everything. All right. So the only difference is that for running the Spark streaming with the external third-party libraries, you might have to download lot of jars. One of the one of the easiest way to do it is that you create a fresh Maven project. Okay, by saying using this, you first install Maven. Maven is a build tool like Ant, like Apache Ant, and then once you have installed it, you can do things like Maven create my project, and once you have created your project, it will automatically create the full structure of your complete project, and will also create an entry point. All right, and also it will have pom.xml. Okay, I can show you this. All right, here. All right, so it's creating the project, you can see. So it has downloaded whatever is required. Okay, so here it has created my app project, and under my app it has created something like app.java along with its test case. All right, so you can have a look. So it has created a simple hello world uh, program. Now, if you want to add any of this, if let's say you are creating a project which will inevitably talk to Kafka or any of these services, you will edit this file, and under dependencies here you will, just like this dependency, just after this line here, you will add a dependency to for Spark Streaming. Okay, that will, and once you have done that, once you have added this kind of dependency, so what you will do is you will take this and here, why it's not working? All right, so if we have modified this and we say package. So it will download all the things that are required and will create your project, the jar. All right. But for us, we can simply download it from Maven repository. Okay. The other libraries, if you want to connect to Kafka, you can mention Kafka here. If you want to connect to Flume, you can mention Flume there, and so on. All right. Or you can simply go to the Maven repository here and search for whatever you are looking for. Here I'm just saying give me everything which is part of Apache Spark. And what I did was I just downloaded the jar of where is Kafka? This one. So I just downloaded the assembly of this one. That's it. And once I downloaded this, that's what I require for rest of my work. Okay, so I have made it available in slash data folder as well. So this jar we require. All right, so now let's try to do the same thing with Kafka. All right, so what exactly is Kafka? Kafka is a queue which has the producer consumer model. There are producers, there are consumers, and the data between consumer and producer can be saved into the disk or can be kept in the memory. Now, these producers and consumers discover each other using Zookeeper, okay, in the distributed mode. There could be many producer and there could be many consumer, and they all talk on a topic. So you create a topic, you ask producers to produce into that topic, and you ask consumers to listen to that topic. All right. So that's what we are going to do. Let's start with let's start with initializing streaming context. So first we create from PySpark import Spark context, from PySpark streaming import streaming context, and then we here we are saying master. Master means here we will be mentioning that we are going to talk to Yarn instead of master, whatever master you want to mention. Okay, and this is the interval. If you want to consume the data per second, it is 1. If you want to say 5, but if you want to consume every 5 seconds. Next is, after the context has been defined, you have to do the following. Define the input sources by creating the input D stream. Define the okay, define the streaming computation by applying maps, reduces, filters, and whatnot. And start receiving the data and processing it using streaming context.start. Wait for processing to be stopped using await termination. All right. SSC dot await termination. The processing can be manually stopped using streaming context.stop. All right. Also, when you are running, do not use local or local1 as the master URL, because only one thread will be utilized for reading or processing the data. It leaves no thread for receiving the data, because it is if The way Spark works is one thread receives the data and puts it in the queue, in the memory queue, and then other thread processes that RDT. Now, always use more than one. If you have number of uh, receivers to run, okay, so always have more than one thread, and always have local n should be more greater than number of receivers. All right. All right. Now, the one which we just did was TCP connection. Okay, you can do the same thing with file streams, as in the file is being appended to or a directory is being written to, or it could be based on custom actors. These are the various sources which are available. Okay, so yeah, I'll remove this keyword called basic here. So, reading from the file stream, we have already covered the reading from TCP, which was very straightforward. Our word count, the first one, was basically based on TCP socket connection. Second is that you can read the files from a directory. All you need to do is streaming context, which is sse dot text file stream, and we say this is my data directory. Okay, so it will basically convert the files in that folder into one RDT at a time. It'll read the data, and you will feel as if the continuous stream of data is coming, and this data will be coming based on all the files present in data directory, or all the files that are being added to the directory. This data directory could be HDFS, could be S3, could be NFS, whatever. Okay, and this Spark streaming will monitor the directory called data directory. Any file added or created or moved into this directory will be picked up by streaming context and processed. All the files must be in the same data format, because we cannot differentiate between multiple files here. Files are created by moving or renaming into the directory. Once moved, the files should not be changed. If you added a file and then you're trying to modify it, it won't pick it up, because it picks up the files only based on added timestamp, created timestamp. All right. Once moved, the files must not be changed. If you are continuously appending a file, then the new data will not be read. All right. So there is something called custom actors. Sometimes you want to customize this. The customization can be done in Scala or Python. The details are available here. All right. Now, sometimes you want to, for testing purposes, you want to convert one of the in-memory available RDD into the streaming. You can do that. You can say queue stream and provide a list of RDDs, and that should be good enough. All right. Now the advanced data sources. Advanced data sources as in Kafka, Flume, Kinesis, Twitter, because these are external non-Spark libraries which are bundled, which have been bundled to work with Kafka, with the Spark streaming. Okay, so these are external. They are not shipped with Spark. That's why you have to download them from the Maven repository. All right, here is the guide. If you want to get into detail, we will go into this one. We will go into Kafka. This details of Kafka will not go into Flumes, Twitter, and Kinesis. All right. So When we talk about Spark streaming plus Kafka integration, let's first understand what exactly is Kafka. Kafka is basically publish, subscribe kind of messaging. It's a distributed, partitioned, replicated commit log service. Okay, distributed as in there are multiple machines on which Kafka runs parallelly, and partition means the data is the you can partition the data across multiple machines. Replicated means in case one node goes down, the work gets shifted to another and everything works fine. All right. For running for running Spark streaming plus Kafka integration, you need Zookeeper, which is already installed. Similarly, Kafka and Spark streaming both are so Kafka and Spark, Kafka, Zookeeper, all three are installed by default by Ambari when you install HDP, Hortonworks Data Platform. And Spark streaming is something you have to download. Okay, you have to download, and I have uploaded it in data slash Spark. Okay, here, here, yeah, it is there actually. All right, so here is the now under data, under Spark streaming folder, you see this library. You can download this. I've already downloaded into my terminal here. Here, I don't need this folder. I just wanted to show you my dash app. Yeah, so here you can see this Spark streaming .kafka assembly. That's what I wanted. Now let's move ahead. All right. Now once we have downloaded that, we can go ahead and we include the essentials first, like this, and then import this. We'll talk about these future import function. All right. Then we create the Spark context called SC, and then we create SSC, Spark streaming context, and then we take these from the arguments, command line arguments, the name of the zookeeper, and then we start the topic, listening to the topic. Kafka utils dot create a stream and Spark streaming context. This is the zookeeper quorum from where we will find out who are the producers, and then we give our program this name. We give this program this name called Spark streaming consumer, and then we say our topic is one. Okay, or our topic is test. We will say test. I'll show you this. Okay, sorry, yeah. Next is once we have done that, we can create the RDD by transforming the actions like map, flat map, and then map and the reduce. So first we break down a line into words, converted word into a tuple, and then we did a reduce, and then we printed it. Okay, and that's how afterwards we just booted the service, and then we waited for its termination. All right, so this is how we will consume, but let's first produce. Okay, to produce we will log in into another screen. Okay, and we'll log in into another screen, and also we will have this export path equals to dollar path this. All right, and then we say this is our topics list. Where is our topics list? We can say it says yeah, so it says unable to connect to. Oh, okay, this is right because the typing mistake is there. Cloud X Lab. All right, let's see. it says test already exists. Okay, let's call it CLS, which is our class name. All right, we created a topic. Let's verify it if it is there. All right, let's verify it. Yes, CLS has been created. Now here we open our Kafka word count. Anyway, I think topic is being picked up from command line anyway. So we have created a topic in the Kafka. Now we'll start producing data. Okay, so let's try to produce the data. Let's try to produce the data. The data which we are going to produce is here. So we are saying Kafka console producer broker list, and this is the topic, and topic is CLS, right? So here whatever we type, we are basically producing data. Okay, now that's about producing data, and then we run console just for testing, is it working or not. Okay, this is our way of testing it. First we are talking about CLS. All right, here we have to find out where is our export path. Yeah, yeah, so data is being produced successfully. Now we have, it has consumed this data which was lying there in the queue. Now we, once we have figured out that everything is working fine, now let's try to run again. We will send, this is our actual command. Rest is for sending the data to dev, sending the errors to devnull. So here we are saying spark submit jars, and then we are saying Spark streaming Kafka assembly, whatever we have downloaded, and then we are providing our word count program. Here we are telling this is the zookeeper, as zookeeper is the way of discovering any service in the network. So in this way it will discover the Kafka service, and then we will provide our CLS topic. All right, let's try to see if it is working fine. All right. All right, it says that nothing is there. Now let's try to produce some data. See, it has figured out this. Now let's go ahead and do the yes thing. Wi-Fi ES pipe. We are sending lot of data now. You can see that 2.3, 23,000, 72,000, 66,000 this time, 82,000. So this is what it is running. Now, where is our 8088? 8088, it's not there. Okay. All right, you can see that. Are we on the H1 only? Yeah, you can see that it's producing around 13.4 lakh Ys per second. All right. Also, what we can do is we can stop this here. Not this. We'll stop this for a moment, and then we will say master yarn. Okay. Is it working? Is it working? Let me first stop the producer. All right. So let me try to see what exactly is going on. What does it say? Bind already in use. All right. All right. Let's consume remaining messages and we will talk tomorrow. All right. There is still wise pending from our previous one. There are wise pending in Kafka. So those are being consumed right now. You can see 22.1 lakh, 3.1 lakh, 3 lakh. So that's the throughput we are getting. And I don't think it's running on. We'll get to know just now. If you go to Yarn and you say Resource Manager UI or Resource Manager Logs, there you can see. Oh, it's running actually. Yeah, it's running on the Yarn only. Nice. So here it's running on Yarn. Interesting. All right, so that's pretty much for today. Yeah, it's running on the Yarn, so our experiment is successful. Now let's see what's going on. So all of you, please try to do whatever we have done today. You try to do it. Otherwise, you will never be able to uh, finish it because you will develop a fear out of it. Okay. So we have everything in place. We have Kafka installed, we have Zookeeper installed, and everything runs fine with this user account. So all you have to do is repeat the steps and try to understand what is it that you're doing wrong. All right, that's pretty much for today. Thank you very much and have a great day. Bye bye. Thank you, Mandy. Thank you, Iswar. Thank you, Gaurav. Bye bye. I hope you liked the session. Have a great day.